Welcome to the April edition of AJP-Heart and Circulatory Physiology video table of contents, or from the editor's desk. This month we have published 2 reviews, 20 original articles, and 1 letter to the editor. Remember, these short videos are starting to reach a greater audience, and I hope you're enjoying watching them. The aim is to just provide you with a taste of what's in each issue. For those authors that I have not highlighted, I apologize, but I believe brevity is the key to listening, and all the science in each issue we believe is first class and highly relevant to cardiovascular physiology. So let's get started. In a very timely review, Hackford and Mishra provide a nice overview of the relationship between the cardioprotective gas hydrogen sulfide and its relationship to modulation of various microRNA signaling events in the heart. This review discusses regulatory mechanisms that maintain normal levels of H2S and the potential for H2S upregulation to be therapeutic. Importantly, it focuses on specific molecular pathways where H2S and microRNA regulation intersect. You'll find this an informative and enjoyable read. Park et al. Studied the impact of chronic exercise on vascular mitochondrial function, an area where few studies have been concentrated. Arteries from sedentary and swim-trained mice were compared for mitochondrial function. Exercise training increased mitochondrial complex 1 and 2 state 3 respiration. Mitochondrial respiratory control ratio was greater in exercised mice compared to sedentary, despite similar levels of citrate synthase activity and mitochondrial DNA content. Exercised mice also showed increased transcript levels of PGC1A and COX4I1, increased MNSOD protein, and increased eNOS. The study shows that training increases vascular mitochondrial respiratory capacity and evidence of improved redox balance. Stelter and colleagues examined the link between hypoxia, cardiac function, and mortality in mice exhibiting a phenotype of Duchenne's muscular dystrophy. Chronic hypoxia resulted in significant cardiac fibrosis. In isolated hearts, short bouts of ischemia impaired function in the DMD mice. DMD hearts displayed decreased cardiac efficiency and oxygen extraction. Isolated myocytes exhibited normal maximal oxygen consumption and mitochondrial morphology. These findings are significant as hypoxia is a common and largely preventable component of DMD that may contribute to the progression of cardiac disease in these patients. Angiotensin II can be made from angiotensin 1 through 12 by the action of chymase in rodent and human hearts. In this study, Ferrario et al. Used transgenic rats harboring the human angiotensinogen gene to assess the non-renin-dependent effects of increased human angiotensinogen expression on cardiac function and arterial pressure. Transgenic rats exhibited sustained increase in arterial pressure, increased heart weight tibial length ratios, and echocardiographic evidence of cardiac hypertrophy. There was a 4-fold increase in angiotensin II and increased Ang 1 through 12 in the myocardium. Chymase activity was not different. ACE and ACE2 activities were not different. The increased Ang2 content in the heart may be the result of a non-renin-dependent mechanism in transgenic rats overexpressing human angiotensinogen. Renin-independent cardiac angiotensin II may have significant effects on cardiac function. Finally, Yamamoto et al. Previously reported an essential role for eNOS in the development of calorie restriction-induced cardioprotection and SIRT1 activation during calorie restriction. In this study, the mechanisms were probed more deeply. Cardiomyocyte-specific SIRT1 knockout mice were subjected to caloric restriction for 3 months. Ischemia-reperfusion injury was assessed in isolated hearts. Caloric restriction showed cardioprotection, which was not seen in SIRT1 knockout mice. Interestingly, the expression levels of cardiac complement 3 was attenuated in wild-type caloric-restricted mice, but not in SIRT1 knockouts. Resveratrol also attenuated the expression of complement 3 in cultured neonatal cardiomyocytes. These data show that SIRT1 plays an essential role in caloric restriction-induced cardioprotection by suppressing cardiac complement 3 expression. Thank you for listening again this month. Or if this is your first time, please forward to your friends, students, and colleagues. As always, I would appreciate your feedback on these videos. Go to the AJP website for the entire April table of contents. Please send us your best work. Our time to decision is only 18 days. Have a great month.